Let's look at another example. So this is an example looking at drinking green tea. 11 healthy people who don't typically drink tea were asked to drink 5 or 6 cups of tea a day, while 10 healthy non-tea and non-coffee drinkers were asked to drink the same amount of coffee, which is caffeine but not L-theanine. So L-theanine is this amino acid in tea, especially green tea, that is thought to sort of improve cognition in a way. The idea is it makes you slightly more relaxed, yet focused, whereas coffee might make you more jittery. So the idea behind this is that maybe drinking tea, especially green tea, which has caffeine and L-theanine, might make you more relaxed and more focused as opposed to just drinking coffee. So these two groups were randomly assigned. And then what they wanted to do after 2 weeks, they wanted to examine the strength of people's immune systems, because not only does L-theanine cause sort of relaxation, but the idea is it might actually improve one's immune system. So this is a real study, okay? Again, published in the very prestigious journal here. The title, it's a lot of highly specialized information, but substantively, right, we have the data set. You have the tools to analyze this kind of study. So let's think about the null and alternative hypotheses. Right? The question here is, does drinking tea rather than coffee lead to a stronger immune system? Right? Their outcome here is this thing called interferon gamma production. Right? It's a lot of words. The point is, it suggests a stronger immune system. Right? So they want to know, does tea lead to a stronger immune system? So the null is that there's no difference in this sort of strength of immunity between the two groups, those who drink tea and those who don't, while the alternative is that the outcome differs for the two groups. So we're going to conduct a two-sided t-test. This is what the data set looks like. So we have these different respondents randomly assigned to these two groups, treatment and control groups, and then we have this outcome measure, which is really a measure of the strength of one's immune system. And the sample size here is 21 people. We're going to conduct a two-sample independent t-test. This is what the results look like. Right? Using the p-value approach, right, we can make a decision, a conclusion. We obtain a p-value of about 0.05241, which is a little bit greater than alpha of 0.05. Thus, under the two-sided alternative, we actually fail to reject the null hypothesis of no difference. We say, well, the difference of these two groups, right, it's not statistically significant at the alpha of 0.05 level with an alternative that is two-sided. So we might conclude that there's no difference between the groups in terms of immune system strength. Now, if you look at the two sample means, right, the mean of those in the group that were drinking tea and the mean for that group that was drinking coffee, right, you can see that the tea drinkers, they had a higher average. The average is about 34.81, whereas the average for those at the coffee group was about 17.7. So you can see there is a difference between the two groups. But because of the amount of uncertainty in the data set and the size of the sample, that's not statistically significant at the alpha of 0.05 level with a two-sided alternative. So you might ask, well, how was this published in this big journal, right? A very important journal. Well, one thing to keep in mind is that the alpha of 0.05 level, right, it's not set in stone. Right? It's really a convention. Okay? So this is sort of a cartoon that kind of pokes fun of this idea that how a lot of researchers really overinterpret the p-value. Right? Look at the actual effect size, the difference of those two means, in addition to the p-value. And in fact, what the researchers really did is what they did is they actually constructed a one-sided test. And with a one-sided test, they actually found a statistically significant finding. Right? The idea behind the one-sided test is, well, of course green tea is going to increase the immune system production. So that's really how we're going to focus the one-sided test. We're not even going to consider the idea that drinking tea might decrease one's immune system. And that sort of setup in which you have a one-sided alternative does lead to a statistically significant finding, although that's less common. It's really much less common to conduct a one-sided t-test. And they might even be accused of sort of gaming their results because a two-sided alternative suggests more ignorance, which is a good thing, more sort of open-mindedness in a way about whether the difference is positive or negative in terms of that difference of two means. So key point here is that this p-value, it tells you about statistical significance, but it's also important to look at substantive significance. And that difference of means is still pretty large, okay? And so that suggests maybe the uncertainty is due to some of the variability in the sample, as well as the relatively small sample size. So a few things to know for this part of our discussion about the difference of two means, okay? We can compare the means of two groups using the two independent samples t-test. The idea here is that you might have two sample means, but you want to use those two sample means from these two different groups to really make a conclusion about two population means. Right? The null for this kind of test is that the difference of means in the population is 0. Because if the difference is 0 in the population, then the means are the same. Right? If the mean of one group is 20, the mean of the other group is 20. 20 minus 20 is 0. So that is the null. And then the alternative for this course, we're really going to focus on a two-sided alternative. And that alternative is simply that the difference is not 0. Okay? That suggests that the mean of group 1 might be larger or might be smaller than that for the second group. But the whole point is that they're different. And then for this course, we will focus on using statistical software to find the test statistics, the p-values, and confidence intervals for this two independent samples t-test, in which we're trying to make an inference about these two population means. And with that, we conclude this discussion of comparing two means.